On 4th April 1981, the first proton-antiproton collision was observed in the intersecting storage rings at CERN. Positively charged protons and negatively charged electrons make up regular matter, while the complete opposite occurs in antimatter, where antiprotons are negatively charged and the positrons are positively charged. When matter comes into contact with antimatter, they annihilate each other, producing charged and uncharged pions and high-energy photons. The energy from antimatter annihilation can be used to accelerate a spacecraft to incredible speeds. There are four main concepts for antimatter propulsion. In pure antimatter propulsion, the charged pions created during antimatter annihilation are funneled using a magnetic nozzle to generate thrust. Energy from antimatter annihilation is used to heat a propellant in thermal antimatter rockets to create an exhaust. This is then expelled from the engine to produce thrust. In antimatter power generation, energy from antimatter reactions are used to generate electricity. The electricity is then harnessed for electrical propulsion methods. In a catalyzed fusion rocket engine, the power output of a fusion reaction is amplified through the use of antimatter. The products are then funneled out of the engine using a magnetic nozzle to produce thrust. The fastest man-made spacecraft so far is the Voyager 1. It is currently traveling at 38,000 miles per hour. An antimatter rocket, on the other hand, could mathematically travel at 72 million miles per hour. There are two chief difficulties when it comes to antimatter rockets. One is the production of antimatter in reasonable quantities to power a spacecraft. Then what's the second difficulty? Well, the storage of antimatter is not easy, as it will inevitably annihilate if it comes into contact with regular matter. Does that mean antimatter rockets are impossible? There are solutions. For production, we just need to dedicate a few hadron colliders, the current producers of antimatter, entirely to the task. And for storage, we just need to make our current trapping methods more efficient. Humans can build these powerful propulsion systems, and they will open the gate to a new era of space exploration.